is Taneti. My register number is URK24AI1077. Today I'll be explaining Docker and Kubernetes Laboratory Explain number 1, that is Introduction to Docker and Packaging an Application with Docker. So our aim is to build a Docker image using VS Code and run the image in a container. So what is Docker? Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications by taking advantage of Docker's methodologies for shipping, testing, and deploying code. You can significantly reduce the delay between writing code and deploying code. You can significantly reduce the delay between writing code and running it in production. So next is the difference between physical machine and virtual machine. Okay, in physical machine we have this web servers, app servers, databases. In virtual machine, it will be like it's not physically present. It's something that is virtual. Now let's talk about Docker images. An images is a read-only template with instructions for creating a Docker container. Often an image is based on another image with some additional customization. For example, we may build an image which is based on the Ubuntu image, but install the Apache web server and application, as well as the configuration details needed to make our application run. Next, let's talk about Docker containers. A container is a runnable instance of an image. We can create, start, stop, move, or delete a container using the Docker API or CLI. We can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. When a container is removed, any changes to the state that are stored in persistent storage disappears. This is the Docker architecture. And next is Docker registry or Docker hub. A Docker registry stores Docker images. A Docker hub is a public registry that anyone can use, and Docker is configured to look for images on Docker hub by default. We can even run our own private registry. When we use the Docker pull or Docker run commands, the required images are pulled from our configured registry. When we use the Docker push command, our images push to our configured registry. Next is Docker installation. The first step is to download the installer using the download button at the top of the page or from the release notes. Then double click Docker desktop installer.exe to run the installer. By default, Docker desktop is installed at our files where it is placed at our path. When prompted, ensure the use WSL2 instead of Hyper-V option. On the configuration page is selected or not depending on your choice of backend. Step 4, follow the instructions on the installation wizard to authorize the installer and proceed with the installation. Step 5, when the installation is successful, select close to complete the installation process. Step 6, start Docker desktop. Uh, this is how we create a Docker Hub account. First, like visit Docker Hub in your browser, click sign up on top right corner, enter our information, that is our user ID, email address, password. Complete the verification process, and then we can log into our new account. So the commands are: step 1, verify Docker version and log into Docker Hub. Docker version or Docker underscore version. Then Docker login. Step 2 is to pull image from the Docker Hub. Docker pull, the command is docker pull nx. Then step 3 is to run the downloaded Docker image and access the application. Copy the Docker image from the Docker Hub. Then step 4 is list running containers. These are the commands for running the containers. Step 5 is to connect the container terminal. Step 6 is to container start or stop. Step 7 is to remove the container. Step 8 is to remove the image. And the procedures are Docker extensions, install the Docker extensions Python and VS Code. Docker file, create a Docker file in your project directory. Create all the dependent file app.py and requirements.txt. Terminal, open the terminal in VS Code, navigate to project directory, navigate to your project directory, build image, so the code is run docker build underscore t and the name of the image. Docker images, run docker images to verify the images docker run our image name. Then to perform port binding, docker run underscore p 8000, 8000 is to 8000. And give our image name. Then access the server we created now, the local host we created now. Okay, so this is the code. This is the code for Docker file, and this is the code this is the Python code for the app.py, and this is the code for these are the things that has to be recorded in the requirements.txt file. Okay. Next is port binding. In this experiment, we run a Flash application inside a Docker container and used port binding to make it accessible from the host machine. The Flask app inside the container listens on port 8000. Docker isolates the container so that app's internal port cannot be accessed directly from the host. To allow access, we use the following command. It's the command docker run underscore p 8000 is to 8000 flask underscore app. Explanation of port binding is the first 8000 before the colon is the host port, that is the port on the Windows machine that we use to access the app. The second 8000 after the colon is the container port, that is the port where the Flask app runs inside the Docker container. This mapping ensures that any request sent to http underscore double slash localhost colon 8000 on the host machine is forwarded to container port 8000 and the Flask app responds. This is the output. This is the finalized output. So the result is the build process completed successfully, confirming that the Docker image was generated and is now stored locally for execution or distribution. Thank you.